What makes a triangle a right triangle? Do you guys remember that from geometry? Or from your SAT class or your PSAT, SAT prep? What makes a triangle a right triangle? It does. It has a 90-degree angle. How do you indicate a 90-degree angle on a triangle? How do you draw that? Or what do you put a little box, right? Okay. All right. So we're going to start. All of our triangles are going to be right triangles. And the corner that you want to, that is supposed to be the 90-degree, you'll indicate with a box. All right. So that is the assumption that there, the 90 degrees goes right there. All right. In a right triangle, we use letters to label the outside edges. A is the vertical edge, up and down. Little b is the base or the bottom. And C is the diagonal side. Now, do you remember from your geometry what the name of that side is, the one that goes diagonal like that? Hypotenuse, right. Okay, so this is called the hypotenuse. Hypotenuse. Hypotenuse is how you spell it. Hypotenuse is how it's pronounced. That is the hypotenuse. Now, between little a, little b, and little c, there was a Greek mathematician who figured out a formula that worked all the way around a right triangle. Do any of you remember what that is? And again, probably showed up, I heard it. Hayden, go ahead. All right, Mr. Pythagoras, okay, Greek mathematician, he came up with the relationship that works for every right triangle, and that is the Pythagorean. It's called the Pythagorean theorem. Do you happen to know what that is? Correct. All right, so this is called the Pythagorean theorem. And the relationship is that the side that's called A, if you square it, and you add it to the side that's called B, and that's squared also, then that will always come out to be equal to the side that is C, the hypotenuse squared. So that is the Pythagorean theorem. It only works on right triangles. It doesn't work on other kinds. If you try and apply that to a triangle that's not right, then the numbers will not work out. But for a right triangle, it always will. And so some of the questions you're going to have tonight are going to look a lot like SAT questions or PSAT if you haven't taken it or you're doing an SAT prep class or something, but they'll look a lot like those kind of questions. And so you'll have something like this, a right triangle with, say, A equals 5 and C equals 13, find B. And so you know it's a right triangle, and so you start, I usually start by drawing it because I like to have a visual of what that triangle looks like for me. A is 5, so that would be the up and down side. C is 13, so that would be the hypotenuse side. And then B is the side that's missing across the bottom. And so since it's a right triangle, I would apply the Pythagorean theorem. So A squared plus B squared equals C squared. So I'll take 5 squared as my A. B squared is unknown. And 13 squared. So most of those, if you know your math facts, you'll be able to work that out without using a calculator, but if you have to check, that's okay. So 25 plus B squared equals 169. So when you subtract 25 from both sides, it works out to 144. So B is the plus or minus square root of 144. Now, again, if you know your math facts, you know that 144 has a perfect square root, and in triangles, the sides are positive, and so we don't use negative values, and so B is just said to be 12. So that would be a sample of, like, very similar to what you would find on a standardized, maybe a math placement test for college, if you are going to have to take that this spring when you register. Okay, let's try another one. So some of your homework will be like this. So maybe you have a right triangle, with B being equal to 4 and C being equal to 8. So find A. So again, I like to have a picture for myself of what that looks like. So if I know B is 4, that's the bottom value. If I know C is 8, the hypotenuse, and A is going to be that missing side. So I'll use my A squared plus B squared again for Pythagoras. So A squared plus 4 squared equals 8 squared. So math facts are A squared plus 16 equals 64. Subtract 16 to both sides, so A squared is 48. And so A is the plus or minus square root of 48. We don't need the negative, but we can simplify. 48 doesn't have a perfect square root. 49 does, but 48 doesn't, but it can be broken up. So 48 could be broken up into 16 and 3, which I do want you to do. I do want you to make sure that you simplify your square roots all the way. So 16 and 3 is 48, so that would be 4 rad 3 would be the answer for A. So any questions so far about the right triangle's Pythagorean? Okay. Good. Okay, so now we go into the other theme of the lesson. That was just right triangle Pythagoras. This now is right triangle trig. In order to do right triangle trig, you need the angles labeled as well. We use Greek letters to do that. The first Greek letter we're going to use is this one. So it's like, it reminds me like a little fishy or something. It's like the number 8 turned on its side, but it's not closed all the way. It's not all the way closed. This is called alpha. Oops. That's the first letter of the Greek alphabet. It's like their letter A. When they would learn their ABCs, they would start with alpha. Does anybody know the second letter of the Greek alphabet? Beta. Yeah. And so beta looks like a capital B, but it has a long little tail to it, and that is beta. There are other Greek letters we're going to learn, but these are your first two. And they go in certain places on the right triangle. So the 90-degree corner needs to always have a square in it. Alpha would always go in that lower corner that is basically going in the upwards direction. Alpha is sitting on the B side of the equation, of the triangle. And then beta always goes in the upper corner across from that. So that's the position that we use. And then we still have side A, side B, and side C. So trig is the relationship between the sides and the angles. Okay, they match up in certain ways. Okay, in trig, you have been, well, in geometry, you were introduced to the idea of sine, S-I-N-E, and cosine, C-O-S-I-N-E, and tangent. When you were in geometry, you learned that sine, cosine, and tangent are all fractions. They're all answered with some kind of fraction. Sine is something that we call opposite over hypotenuse. Okay, the opposite, well, everybody knows where the hypotenuse is. That's always C. The opposite is when you stand on that angle and you look across, what side do you see, okay? So it's what is opposite. So it's like I'm sitting here looking at Trevor, and Trevor is exactly opposite of me. But you guys, all of you have different perspectives. Someone else might be opposite from you. So it depends on what corner that you're standing on. And so if I am standing, if this is the picture, and I am standing here at angle alpha, then looking across, I see side A. That is the opposite when you're standing there. But if you put yourself at angle B, at angle beta, then your opposite is side B because you're looking directly across. And if you put yourself on the right angle and you look directly opposite, you're looking at side C. So you got to know what corner you're going to be in to know which one is going to be the opposite for you. All right, cosine is adjacent. Adjacent is a word that means next to or alongside. And that's adjacent over hypotenuse. So again, it depends on your perspective. Which angle are you on, and what is directly next to you in that situation? And then finally, tangent goes back to opposite again. And then over adjacent in the denominator. Okay, these words, these fraction relationships, lead to kind of a silly little memory trick that we use in trig using the first initials of everything. So if you look at S and you compare it with O and H, and you take the first three initials, okay, that spells so. You remember that from geometry? So, and then it was katoa. Yeah, and that comes from the C in cosine, and the A in adjacent, and the H, and then T, O, A. And so those initials lead us to S-O-H, C-O-H, T-O-A. This is called SOHCAHTOA trig. SOHCAHTOA is just a nonsense word that we use to help us remember the order of sine and cosine and tangent. So this is how it's going to go in a triangle. We abbreviate using the first three letters. So S-I-N-E becomes S-I-N. And then when you put an angle in there, followed when you abbreviate it, you put an angle in. So let's do sine alpha. So basically that means, all right, put yourself in the alpha corner. Okay, it's like boxers going to their different corners, right? Put yourself in the alpha corner, look across from you, and what you should see is the opposite side. So that would be A. And then hypotenuse would go underneath, and that would be C. And so we say that the sine of alpha is side A over side C, A over C. And then we abbreviate cosine, C-O-S, and if we do that from the alpha corner, so always when you abbreviate, you follow it with parentheses and you put the Greek letter in. You put yourself in the position, well, now I need adjacent, and what's next to me when I'm standing in the alpha corner is B, still over the hypotenuse of C. And then finally, we abbreviate it with tangent of the alpha corner. And we go back to what's opposite of that, and what's opposite of that is A. And then adjacent to that is B. So your answers are going to be a whole bunch of fractions, just fraction over fraction over fraction. It'll just a list of fractions for your homework responses. It's not going to take a ton of math unless you're doing the Pythagorean theorem, but otherwise it's just going to be a list of values. Okay, now depending on the corner that you're at, so you could do a different corner. I'm going to switch colors so I match to green. I can do sine from the beta corner, and cosine from the beta corner, and tangent from the beta corner as well. It changes your perspective. When you're in the beta corner, opposite is different. Okay, so if you're in the beta corner up here, and your sine, which means you need to look opposite, you look across, and you're like, oh, well now my opposite is B, but my hypotenuse is still C. And so sine of beta is opposite over hypotenuse. Where else have you seen B over C before? Yeah, look. B over C is here. It's also here. Okay, in other words, the cosine of alpha and the sine of beta are the same thing. Work out to be the same thing. All right, when you get to cosine of beta, you're back up at that perspective. You're like, oh, what's adjacent to me? What's right next to me? What's right next to that is A. So that would be A over C. And again, we notice that that has happened before as well. That was right here. And then tangent of beta. Again, beta corner. So opposite is B. Adjacent is A. So that would be B over A. That's never happened before. B over A is unique. But it is kind of related to A over B, and that one becomes B over A if you switch the corner. Okay, any questions on that so far? Okay, so let's try one of those. This mostly should be review. All right, so find this trig values. And I'm going to, sometimes you get a full triangle, and sometimes you don't get the whole triangle at all. Okay, I'm going to give you a full triangle. Okay, there's your corner. I'm going to give you alpha. I'm going to give you beta. Oops. And I'm going to give you 3, 4, and 5. Okay, so I want to ask you then to, list the trig values for that one, and they would, you'd either say, okay, list the trig values for alpha, or list the trig values for beta. I'm going to say let's start with alpha. No, let's do beta instead. I want to do beta. All right, sine beta, cos beta, tan beta. Okay, Sarah, can you give me sine beta? So put yourself in the beta corner, and then think about sine and what the acronym is for sine, and what would be opposite for that.
So it would be 4 over 5.
Very good. All right, so 4 over 5. Awesome. All right, Sam, how about cosine beta? So putting yourself in that beta corner, what would be adjacent to you? Mm-hmm. Good, 3 over 5. Okay, awesome. Okay, Angie, how about tangent? This is going to be TOA, so opposite over adjacent. Okay, opposite is 4 over 3. Great. Okay, now, those are the primary trig values. There are 3 more trig values. So we're just going to do them side by side. And here they go. Okay, we're going to work our way up from the bottom. Cotangent. Okay, that's the word. And we'll talk about the abbreviation in just a minute. And then something called secant. And then finally, cosecant. I want you to see the pattern that kind of goes. There's always patterns and rhymes and rhythms and stuff in trig. Okay, I want you to think of the words. We do sine followed by cosine, right? Okay, sine followed by cosine. And I want you to note the order. Then we do tangent followed by cotangent. You see how it's sine, cosine. You just add the word co. Tangent, cotangent. Add the word co. And then secant, cosecant. Add the word co. So if you follow kind of that pattern of going down one row and then up the other, that'll help you remember the order that they go in. Okay, let's talk about the abbreviations for those. Okay, Does it work to take the first three letters? All right, well, if we take the first three letters, that would be COT. And if we take the first three letters, that would be SEC. And then if we take the first three letters, we get COS. What do you think about those for abbreviations? Can't use COS. Why not? Okay, I already, so then, because how would you tell the difference, right? So the only one we can't do that for is cosecant. And so what we do instead is we use the first three consonants, right? You know the difference between a vowel and a consonant? Okay, so what would the first three consonants be? Okay, so that is the abbreviation for that one, CSC. Okay, now depending on, let's do the beta corner again, since we were working with that anyway. Okay, these are so easy. If it's the same corner as what you were just working with sine, cosine, and tangent, then you just flip them all upside down. You take the reciprocal. All right, so the reciprocal of 4 over 5 becomes 5 over 4. The reciprocal of 3 over 5 becomes 5 over 3. The reciprocal of 4 over 3 becomes 3 over 4. As long as it's the same letter, right? As long as beta corner matched beta corner, then you just got to do these three, and then you pretty much have those three as a slam dunk, because they are, now it's really mean when somebody changes, like change that. So if they change that, then you got to figure the other one out first for the other letter, and then know your answer. That usually it'll match. Okay, so those are called the 6 trig values. So if you're ever asked find all 6 trig values, that's what you've got. Okay, so let's keep going. Now that triangle, you had all the sides to begin with. Here's one where you won't quite have so much. Okay, find all 6 trig values. Okay, upside down triangle this time. 3, 10. All right, what is missing? Okay, A is missing, so I'd have to figure that one out. What else is missing? Alpha and beta, you got to decide the labeling of where you're going to put each one. Okay? Okay, this is basically flipped upside down. So in your mind, flip it right side up and think about where you'd put alpha and beta if it was right side up. And that's the same place you would put alpha and beta when you flip them upside down. And so if I flipped this right side up, it would look like this. And so beta would go up in that corner, which means beta has to go down here. Oops. And then alpha would be in this other corner over here. Okay. Before I find all 6 trig values, I have to know what A is. Okay, I can't do the 6 trig values if I haven't figured out the value of A. And so we'll sort of step to the side, and we'll use our trusty Pythagorean theorem, a squared plus b squared equals c squared, to help us figure out the missing side. So a squared plus 3 squared equals 10 squared. That's a squared plus the math fact of 9 and the math fact of 100. So a squared is 91, and so a is the plus or minus square root of 91. A 91 is not a math fact, and it can't be broken up into anything smaller. And in that case, we would simply just leave it as the square root of 91. Okay, there's nothing else we can do to that. We can't break it down. Okay, so now we can find the 6 trig values. And they would tell you which corner to focus on. I'm going to tell you right now, let's do it with the alpha corner. All right, so it just depends watch the problem for which one they ask you to do. So we'll do sine alpha, cos alpha, tan alpha. And then we'll follow that by cotangent alpha, secant alpha, cosecant alpha. Okay, Dylan, can you do the first one? Sine of alpha, which is so. What is opposite alpha? Good. Okay, square root 91 over hypotenuse 10. So we might as well do the cosecant since we're right there anyway. 10 over rad 91. So I might as well get two done at the same time. Okay, Alina, can you do cosine alpha? What's adjacent to? Three over 10. Because adjacent to alpha, what is next to alpha is the number 3. And so secant would be 10 over 3. Okay, all right, Natalie, how about tangent? Tangent is TOA. Okay, TOA means opposite. And so we need to go opposite. 10 is a hypotenuse. So we need to go opposite, which means not the 3 or the 10, but opposite of that is the number 91, rad 91. Okay, so rad 91 over 3, and then 3 over rad 91. You do not have to worry about there being a square root in the denominator. That's fine. Okay, it's fine to leave it that way. You're not required to change that around. All right, let's keep going. Okay. Find all six trig values if you don't have a drawing. All right, so how in the world do we do that if we don't have a drawing to work with? All right, this is what you're going to do. We're going to sine, cosine, tan, and then I always just write them all out so that I'm ready to go. Oops. C. Oh, goodness. There we go. Cosecant. Okay. If they don't give you a drawing, they have to give you one of the, you have to have something, right? So if they don't give you a drawing, maybe they're going to give you one of the values. So that's what I'm going to do right now is I'm going to tell you cosine of theta is 5 over 11. This is a new Greek symbol. We haven't talked about this yet. All right, so I'd like to talk about that. It's a circle with a line through it. It is the Greek letter theta. It's their equivalent of the letter T. Okay, theta. It is not pronounced with an F. Some people mispronounce it and they say it like that with the letter F. That is not right. Okay, what is that actually? Those of you who are food connoisseurs. That's a kind of cheese. Okay, it is not a Greek letter, so it is not that. Okay, Greek cheese. Greeks did like feta cheese. Okay, so when you have theta, that means you can put it anywhere you want. It doesn't matter if it's in the beta corner or the alpha corner, you can decide. And you can draw any shape of triangle that you want. Okay, right side up, upside down, sideways, however you want to draw the triangle, it is your choice. Okay, so I'm going to draw my triangle like this. I can put theta wherever I want. Does not matter. So you could choose to put theta here, or you could choose to put theta somewhere else. It doesn't matter. Yeah. No, not theta. Theta, yes. No, okay, no, you cannot put it in the 90-degree corner. Sorry, I should specify. The 90-degree corner has to be the 90-degree corner. You can't put it there. All right, now, Cosine is 5 over 11. That's the CAH. That's the adjacent and the hypotenuse. So this fraction right here clues me in to how I can start labeling my drawing. 5 has to be put on the adjacent side. 11 has to be put on the hypotenuse side. And so I'm going to put 5 here adjacent, and I'm going to put 11 here as my hypotenuse, which means I just need to figure out the mystery side B of my triangle right there using Pythagorean theorem. And so even if you don't have a drawing given to you, you can do the drawing yourself. You put theta in the corner where you want, but then make sure you put the 5 and the 11 in the corresponding places. All right, so now I can figure out, I'll do a little Pythagorean theorem on the side over here. So 5 squared plus b squared equals 11 squared. That's 25 plus b squared equals 121. So b squared is 96, which is the plus or minus square root of 96. Now 96 is a math fact that can be split up into rad 16, rad 6. Okay, that's how we get 96 from rad 16 and rad 6, which means 4 rad 6. So now I know that my last side of the triangle is now going to be 4 rad 6. Which means I can fill in everything else. Once I know that that's 4 rad 6, then I can finish the rest of the trig. Please remember, anytime you abbreviate trig, there has to be parentheses and a Greek letter that comes after it. You can't just like write the word sine with nothing after it, okay? The word sine with nothing after it is just, all that says is sin. Okay, we don't want any sin in here. Okay, we only want sine. I will forgive you, of course, if you do that, but we want to put our Greek letters in. Okay, so then sine is now what's across from that. And so what's across from that is 4 rad 6 over 11. And then tangent, where again we're going to put our theta. And so we want TOA, so we want what's across from that, 4 rad 6, and what is adjacent to it over 5. So now we've got the first 3, which means the second 3 come really quickly. The second 3 are fast. Make sure you put theta in all of them. And then flip the values. So 11 over 4 rad 6, 11 over 5, and 5 over 4 rad 6. And again, it's really okay to leave the square root in the denominator. Okay, any questions so far? All right, what was the first thing I had you do at the very beginning of the lesson? No, before that, like before we even started taking notes. Nope. I had you get your calculator out, right? So I had you get it out for a reason. So hopefully it's still out because you're going to need it for the last 2 questions. All right, here is the last 2. Solve for x. All right. Here are 2 triangles. Both of them have x in them. Will have x in them when I finish drawing. Okay, in this one, x is here. And this one, x is here. And this is 23. And this is 15. And alpha is 34 degrees. And beta is 39 degrees. All right. When you are asked to solve for x, I think it's helpful to write down what you were given, just to take a note of it, all right? So I'm just going to look at here. I was given alpha, okay? The 15, what side is that compared to alpha? It is opposite. So I was given opposite. And I was given, or I'm asked about x, and x is labeled, and what side is that? Hypotenuse. All right, if that's what I was given, what trig should I use? I was given alpha, opposite, and hypotenuse. Take a look at those letters there, the O and the H. Okay? Okay, that is sine. Okay, O and H is part of sine. So I want to use the sine formula to solve this problem. All right, so the sine formula is this. Make sure you write it all out. Sine alpha is opposite over hypotenuse. All right, now we're going to drop the things in. Drop the numbers. Sine of 34 degrees. Opposite is 15. Hypotenuse is x. Drop a 1 under the sine 34 so that you can do what next? Cross multiply. It's our favorite thing to do. Okay, if you drop a 1 under there. Okay, so that's 15 equals x sine 34 degrees. How do you get x by itself? Divide. And so x by itself would be 15 divided by sine 34. And that's when you needed your calculator. Okay, so making sure that your mode is in degrees, you would type 15 divided by sine 34 and then come up with whatever you're going to come up with. Who's got their calculator still out that can type that in? Yeah, Trev, you had it already? Or no? Somebody going to beat you to it? 2, 6, point, give me 3 decimal places. 824, great. Okay, so let's do the same thing with this next problem. Look at what you're given. Okay, I was given beta. Across from beta, I was given the opposite again. And I was given hypotenuse again. Okay, because 23 is opposite of 39. Okay, if 23 was in a different place, if the 23 hadn't been right here, if the 23 had been over here, then 23 would have been the adjacent side, and I would change what I was given to thinking about, oh, now I'm using adjacent. So depending on the positioning, it helps to think about that. Then I look at those letters, I look at A and H. A and H are part of, so ca. So then you would use cosine. So this would be cosine beta is opposite over hypotenuse. So cosine of beta was cosine 39 degrees. Excuse me, not opposite, adjacent. The adjacent is 23. Hypotenuse is x. We do a cross multiply again. So 23 equals x cos 39. And you divide both sides by cos 39 using your calculator. So it's real similar to what we were doing last semester with the cross multiplying. We're just using degree mode on our calculator now. So you want 23 divided by cos 39, whatever that comes out to be. Those of you who are faster at it than me, Sarah, maybe, oh. All right, 29.595.